All right, what's going on with the data for the vector analysis lab? As I talk through in the instructions, you can see that the piracy point data doesn't display in the right place. It is actually displaying in the right place, but what's wrong is that it's missing its spatial reference file. So all spatial data is plotted up on a grid that has a specific origin that can be anywhere in the world, a 0, 0 coordinate pair, and then a unit of measure that defines how you're going to measure your coordinate values away from that margin, or I mean that origin. So if we look at, let's look at the properties for this data set. I walked through this in the instructions. Sorry, that went off the screen. If we look at the source, our spatial reference is unknown. So looking at the spatial reference for the pirate points, it's an unknown coordinate system. This file is missing. So we don't have any way, ArcGIS doesn't have a way. It doesn't know what framework, like what origin, where that is. So it doesn't know where to start. Here's the important thing though. These values that are in the extent are actually embedded in the data, but the units are not. And so this is a frustration with me with ArcMap and ArcPro. A previous version of ArcPro had question marks here. And even before then it said unknown, or they've gone through so many iterations, I can't keep track. Right now, it's I think putting degrees here because it knows that these values are so small that this is what it's supposed to be. But this is very misleading because Arc doesn't actually know what these are. This is a guess because the spatial reference is missing. Oh, I hate ArcGIS so much. Golly. Oh, I hate it. Okay, so looking in the file Explorer through Windows, this is what the Assam data looks like. It can't be. What is happening? Okay, so looking in our file Explorer, this is the Assam data. These are the points. And notice that it's represented with a lot of different file extensions, different file types, but they all draw up in ArcPro as one unit. These are all aliased behind one unit called a shapefile. Now a .shp is what we call a shapefile, but this is different than what you see in ArcGIS. What you see in Arc is all of this compressed together. If you tried to display this .shp in Arc, it wouldn't work, and I talked about this in the first lab. Okay, so what this SHP is, when we look in Windows Explorer, is the geometry. These are the coordinate values that tell Arc where these things are supposed to draw. But what's missing here is that spatial reference file. If we look down at the Caribbean islands, we can see this thing called a PRJ. This projection file is how ArcGIS knows where the SHP, the coordinate pairs, what framework they belong on. Where is the origin for these coordinate pairs? This is where that information comes from, and that's missing here. It's a file that can get deleted, and that's actually what I did. I deleted it so that we could have this conversation. The DBF is the database file. This is where all the attributes are. So when you go into a data set and you open the attribute table, see how big this is? This is something you could open in Excel and just look at, the raw attribute data. These are the coordinate values. And this thing down here, this PRJ file, is where the origin is and what the units of measure should be for that origin. So what we need to do is create one of these PRJ files for this data set. And in the instructions, I walk you through running define projection. Define projection creates a .prj file for this data set. We could test this. So like I talk about in the instructions, when we look at the properties, a little bit of cooperation. Sorry, it's off the screen. The extent values, like I said, these are in the .shp file. This is a frustrating, misleading thing that ArcGIS Pro does. But they're small values. So what we're going to talk about next week when we get into coordinate systems is the difference between a geographic and a projected coordinate system. Suffice it to say for now that these are being measured in degrees, like it's guessing, and these belong in a geographic coordinate system. So when we define this, we have a choice. We have a choice between geographic and projected coordinate systems. If you choose a projection file, it's going to assign units of meters to this data. And it's going to draw up in this tiny little location because it's saying that those extent values that go up to a min and max of an absolute value of 180 are in meters. And so they're going to drop as a data set, a global data set that's 360 meters across. And we can test that. You can see that this is the shape of the world. We've got South America and we've got Africa here, and then the points around it. So let's grab our measure tool and we'll measure it in meters. And I'll go across here, and you should see we're at about 360 going across this data set. So it's 360 meters across because meters have been assigned to what should be degrees. I know this is confusing, but it's such a simple concept when you wrap your mind around it. And I think the key is understanding that the extent values, I'm going to the properties again, this is for a projected data set. And if you look, you can see that the values are absolutely enormous. These are only changed when you reproject the data. And that's a different tool than define projection. Define projection doesn't change these. It just says, okay, we're going to tell it where the origin is and what the units of measure are. And you have to do that right initially. Now that, like, for example, this data set is correct, we have a projected coordinate system that goes along with it, and I can show you that. The spatial reference says projected coordinate system. The units associated with that are meters. It's a plane. And so meters are associated with these enormous numbers, and these should be enormous because it's a global data set. So we're up to 20 million meters away from the origin. And that makes sense for the world, right? To change these, we can change this data set back to a geographic coordinate system, but in order to recalculate these to degrees, you run a tool called, I'll show you. It's called project, not define projection. And this is just trial and error, really, truly. But so if I hover over these, projects spatial data from one coordinate system to another. What this tool does is it recalculates those coordinate pair values into a different framework. So a different origin, different unit of measure. And you can project data, even though that's it should be called transform, because you're actually transforming data from a flat surface to a curved surface if you run this tool and change it from a projected coordinate system back to a geographic coordinate system. It's called a transformation. So this is a bad thing on ARC's part. Define projection, if I hover over this, come on, overwrites the coordinate system information. That's that .prj file, the one that's stored with the data set. So this is when it's unknown or incorrect. But the project file actually recalculates those extent coordinate pair values. All right, so that's what you're going to run on here. You're going to run define projection because the extent values are just fine. We just need to tell ARC, yes, it belongs in degrees and where the origin is. And that happens automatically when you assign it the World Geodetic System of 1984. Okay, it's really cool when you get this dialed in. And this does happen all the time. When a data set plots up really small, it's an easy thing to fix, and you're going to get a couple chances to practice that this semester. All right, let me know if you have questions.